Hi and welcome to part 2 of the quotient rule. If you haven't seen the first part of the quotient rule, then I would certainly suggest that you go and do that. And also, if you haven't watched the chain rule video, please go and watch that as well, because this one is going to get absolutely crazy. So what I'm going to do for this one, I've got one function divided by another function. What I'm going to do is I'm going to split that up into u and v. Okay, so u being the top, log e of x squared plus 3x, and v being x squared plus 4 all to the power of a half. Okay, and now what I'm going to do is I'm going to use the chain rule to get the answer to these ones here. Okay, so I'm going to say that that's, the k is x squared plus 3x. Here I'm just going to add in a variable, and so therefore u equals natural log of k. Okay, and I'll do the left hand side first and then come back to the right hand side. So then the derivative of this one with respect to x is fairly straightforward, 2x plus 3. The derivative of natural log of k with respect to k is just 1 on k. Okay, so then I guess to get the derivative of, to get du dx, which is the thing that I actually wanted up the top, that's just going to be 2x plus 3 all multiplied by, brackets around there, multiplied by 1 over x squared plus 3x, which ends up being 2x plus 3 over x squared plus 3x. Okay, now I'll look at the right hand side. Okay, so if v equals x squared plus 4 all to the power of a half, then I'm going to say that h equals x squared plus 4, so this bit in the middle, and v equals h to the power of a half, just using the chain rule again on this. So dh dx is just 2x, and then dv dh is going to be multiply everything by a half minus 1 from the power. I end up getting 1 over 2h to the half. Okay, when I multiply those two things together, I get 2x multiplied by 1 over 2 times x squared plus 4 all to the half, which ends up being x over x squared plus 4 to the half. Don't do some silly stuff by saying that the bottom ends up being x plus 2. It doesn't ever. Okay, you can't just do the square root of x squared and the square root of 4 because it doesn't work like that. The whole thing is to the power of a half. Okay, and now here this is where it gets really ugly, because I haven't actually really even started on my question. The question, remember, the original question is find the derivative of this. So I need to get the bottom times the diff of the top minus the top times the diff of the bottom all over the bottom squared. This is going to get ugly. So I get v times du dx minus u times dv dx all over v squared. So I'm writing this down. V, which was x squared plus 4 all to the power of a half. You have to believe me because you can't quite see it in the screen, but it is true. You can have a look at the notes that are on Schoolbox anyway. Multiplied by du dx, which is 2x plus 3 all over x squared plus 3x. That's why it's really helpful to write all this stuff down, because there's no way I'd be able to do this in my head. Minus u, which I wrote up before, which is x over x squared plus 4 all to the power of a half. I will just check that to make sure that that's true. Sorry, I was doing the other way around. U is actually log of x squared plus 3x, sorry, and then dv dx is actually x over x squared plus 4 all to the power of a half. So, because what I usually do is that the bottom times the diff of the top minus the top times the diff of the bottom. Anyway, we've got the answer there. All of that is over v squared, which is the square root of x squared plus 4. When you square that, it can get rid of the square root sign, so you're just left with x squared plus 4. Okay, we are not done yet. There are still more things that need doing, because I don't like fractions in fractions. So what I'm going to do, and again, if this is tricky or troubling for you, just push pause, rewind, go back and watch it again. But now I'm going to get a common denominator. So I'm just going to tidy these up a little bit so that I've got the two fractions, one minus the other, and then I'm going to get a common denominator of both of them. So I get 2x plus 3 all multiplied by the square root of x squared plus 4 all over x squared plus 3x minus x log, natural log of x squared plus 3x all over the square root of x squared plus 4. Okay, and then to get a common denominator, I'm actually going to multiply these two things together, the bottoms together, and then I'm going to multiply the top by x squared plus 4, and then this top by x squared plus 3x. Okay, this question is psycho. So I got a common denominator on the bottom, or on the top of the bottom of the top, I should say, x squared plus 3x multiplied by x squared plus 4. Now when I multiplied the square root of x squared plus 4 by itself, that just got rid of the square root sign, and I multiplied this one by x squared plus 3x. Hopefully this is making some sense in what I'm doing. It's like if I've got a over b minus c over d, and you want to get the common denominator of this, you can make the common denominator bd, but it means that you have to do ad minus cb. Okay, that's essentially what I've tried to do. If that doesn't make sense, maybe just ignore this question for a little bit and ask me about it by email or in person. So again, I'm still not finished. That's all over x squared plus 4. Okay, and now what I can do is I can remember this little trick over here, and I like to write these down because otherwise I forget them. If you've got a fraction up the top divided by another number, then what we're essentially saying is the fraction divided by c. So those two things are exactly the same thing, just written a different way. Now whenever you divide by something, it's always a fraction. So I can actually say that I'm dividing by c over 1. Now we always know that when we divide by a fraction, we flip and multiply. So this ends up being a times 1 over b times c. I guess another way of looking at this is if the fraction's up the top, then you can drop the bottom part of the fraction down to the bottom. Okay, but I always write these things down. It's always very helpful. The other one I write down is when you've got something divided by a fraction. Okay, and that ends up being a over 1 multiplied by c over b. But anyway, that's something for another time. So I end up getting 2x plus 3 multiplied by x squared plus 4 minus x times x squared plus 3x, all in brackets, and then the natural multiplied by the natural log of x squared plus 3x, all over this thing down the bottom. Now when I dropped this part down the bottom, I actually got the square root of x squared plus 4x multiplied by x squared plus 4. No, not 4x, sorry, x squared plus 4. These are exactly the same thing. This is to the power of a half, and that's to the power of 1. Whenever you've got to the power of a half multiplied by to the power of 1, you can actually add the two powers together and end up getting 1.5 or 3 over 2. Okay, there's a lot in this question, so I hope I haven't lost you along the way. But that's the final answer that I get. Even though it doesn't look nice and it looks horrible actually, that would be the final answer that I get. I guess some people might argue that you could split these two terms up and then cancel the things down, but I don't think there's any need to. That's the answer that I get. Hopefully that has made a little bit of sense. If it doesn't work, or if you don't like it, maybe skip it and do some of the other questions and then come back to this another time. That kind of completes the videos on calculus. In the next video series, I'm going to look at applications to calculus, so working out minimums and maximums and drawing graphs and a whole bunch of other things. But that's it for now. Thanks.